Good afternoon, morning, evening, middle of the night, whatever it is for you, PBA geometry class. This is just a highlight video to review some of the questions I've gotten for the chapter test review. Hopefully you can catch this before you actually take the test, and maybe it'll help you. One of the questions is number 3. You have the figure up on the whiteboard here. You have a trapezoid here. You have two different figures, two different polygons. One of them is a triangle, and then a trapezoid as well. With the information that you are given, you are not able to figure out what the lengths are here, because this 9 is talking about the gap from here to here and not the whole bottom of the triangle. One of the questions was asked, and I saw that, and I didn't see where that 9 was going, and so I had to correct it. So you have a regular trapezoid basically. With the information you're given here, you can figure it out. This is the formula over here, off to the side. 1/2 a height times base 1 plus base 2. So if we take our 1/2, and our height tells us is 10, and our base 1 is 18. But what is base 2? Well, if you see, you got 18 here. That's 18 there as well, because they're telling you in the thing that it's parallel. So 18 plus 9. So we have 27. So 1/2 of 10 is 5. And 18 plus 27 is 45. Five times 45 is 225, and that is your answer. All right, now we're going to look at number 11. We are trying to figure out what is the arc length here. The arc length going from A to B, that's the measure of AB, and that little symbol above it meaning arc. Well, we know that it is 108 degrees, and the radius is 17 from P to B. So we have, this is our formula over here. That is the formula for a measure of an arc length. It's MAB over 360. So the measure of the line AB, so it would be 108 over 360 times 2 pi r, and our r is 17. So now we just got to figure out the calculations. 108 divided by 360 equals 0.3, and if we have 2 times pi, you can use the pi button or round off 3.14, times 17 gives us 106.76. Well, we take that and multiply it times 0.3, and we get an answer of 32.028. And that 32.028 is the measure from the arc length for A to B. And the 32.04 is the answer in the book. 32.028 is what I got on the calculator because I didn't use the pi button. So I'm looking for 32 point something. So as long as you got something close there, that will work out. And so this is another one of those formulas you need to make sure that you have before you take the test. Okay, so number 13, we are looking for the measure of the angle of GH. So here we are given G to H, we're given the arc length, we're given the radius, and now we've got to figure out what was that angle inside here. And so if we look at the formula we just used for number 11, we have the arc length GH equals the measure of the measure of the angle GH over 360 times 2 pi r. That's the formula we just used. So if we rearrange that formula, because what we're trying to look for is the measure of GH. We have the arc length and we have the radius, and so we're trying to look for this. So if we divide 2 pi r on both sides, we get the the arc length GH over 2 pi r equals the measure of the arc length angle over 360. And now, formula-wise, if we are dividing by 360, we can multiply by 360 and multiply by 360. So now all we got to do is fill in the information that we have. So we got 360 times the measure of GH, which is 35, over 2 pi r, which is 27, equals the measure of GH, of the angle there. Okay, so now you have to just figure out the math there. We have 35 divided by 2 times pi times 27. So if we take that number and figure it out mathematically, we get 0.206. So 360 times 0.206 gives us 74.3. Sorry, 74.3. So that is our measure of G to H. So the answer to number 13 for the angle is 74.3. You may get something similar. It may be 74.2, 74.5, but along those lines is how you work that out. Alright, on number 14, we are looking for the area here. So it's a little bit different than what we were looking for perimeter and arc lengths and things like that, because we're talking about the outside. Now we're talking about what comes on the inside. Just like you have circumference equals pi times d, you will have the area of a circle equals pi r squared. You're going to be working with pi r squared here. So the area of a sector, because it's not talking about the whole circle, it's just a sector, the section that's filled in with the squiggly lines there. So the area of the sector equals the measure of QTR over 360, so we're basing off of a 360 degree circle, times pi r squared. Okay, so pi r squared is in here because we were talking about the area of something. So to figure out what the area of the sector is, we have the measure of QTR. That's Q, T, and R here. So this whole section right here. Well, if we know that this pi section right here is 105, we don't use 105 in our equation because we're looking at 360 minus 105. That is what's left. That is what's filled in over there. So that's 255. So we take 255 over 360, and then we're going to multiply that times pi, which is 3.14, times our radius, which is 8, squared. Okay, so 255 divided by 360 equals 0.708. And then multiply that times 3.14 times 64, because that is 8 squared. And that gives us 200.96. So we take 200.96 times 0.708. We get 142.27 and other numbers as well, so we can just call it 142.2. So that is the area of the sector. This is another one of those equations that you have to have a formula. Make sure you have these down. If you don't have them in the back of the book already written down, you can write these, add them to your test worksheet to help you out on the test before you take it. Alright, number 16. We're looking for basically the same thing we just did, except we're looking for the radius. So all these are just different questions using the same formula, but looking for a different part of the formula. So if we find the area of the sector, RPS, like we just did, we found that by taking the measure of RPS, the angle, over 360, and we multiply that times pi r squared. Okay, so here it's telling us that 36 is the area. On the question, it has it labeled a little bit better, it's running out of room. So 36 is our area of that sector. And it tells us that 114 is the measure of that angle. And it tells us that we have 3.14 times r squared. So now we just got to take the measurements and figure out what exactly is happening here. Alright, so we took 114 divided by 360, got 0.31. So we take 36 equals 0.31 times 3.14 gives us 0.973 r squared. Okay, so we got to divide both sides by 0.973. And r squared equals 36 divided by 0.973 actually gives us a larger number than 36. 36.9. And we have r squared. Well, we need to square root both sides. So r is going to equal the 6.8. And 6.8, 6.02, depends on how you round that. I misspoke, it's 6.08 according to my calculations, 6.02 according to the book, and it all depends on where you round and if you use the pi button rather than 3.14. So as you can see, the answer for the radius will be 6, 6.1, 6.02, somewhere around that frame. That's what we're looking for there. So basically, you're taking the same formula you did just a minute ago and you're plugging in different numbers to solve for the different variables. When you get down to the end, you have r squared, so you're going to have to square root both sides to get a radius of 6.08. So that should help you. If you have any more questions, please feel free to ask. It'd be great if you watch this before you take your test, and good luck on it.